Alright, good morning. Hope you guys are all doing well out there. Today we're going to start in on lesson 6.3, which is on logarithms. And what logarithms are used for is if you are trying to find the answer to an exponential equation. So what I mean by that is so far what we've been doing is we've been saying things like if you have $10,000 and you invest it for 5 years at 8% interest, how much money will you have when you are done? Which is a good question to ask. But sometimes you want to come at it from another direction. So for example, you might say, if I have some money to invest at 8% interest for 10 years, how much would I have to invest in order to end up with $50,000? Okay, and so that's what logarithms are for. Very simple idea. I'm not sure why we're doing these guys here, but if we're going to solve the equation 2x equals 8, 8, you do that, of course, by dividing both sides by 2, because that's the inverse operation, and you would get x equals 4. If, however, you are asked instead to solve 2 to the x power equals 8, our problem here is that there is no inverse operation that we can do that can get rid of a variable in the exponent. If we knew what that variable was, then we could, if we knew it was to the third power or something, we could cube root both sides. But it's to the x power, it's a variable, so we don't have anything for that. So the only way that we can do that right now is to just guess and check and think to ourselves 2 to what power is equal to 8. And that answer is obviously 3, but notice that that only works out in that case because it came out to be a nice easy number. What if instead the question had said something like 2 to the x equals 15? 16 would be easy. Then what would x equal? We could look at a calculator and keep raising 2 to successive powers and do a guess and check until we figured out what x was, but that's kind of inefficient, and we don't like to do a lot of guessing and checking in math classes. We like to be able to follow some steps and get an exact answer, and so that's what we're going to start working on today. The answer to all of those questions is logarithms. So what a logarithm is it takes an exponential function. So it takes something written in the form of some number to a variable equals another number like that, and it switches it around. They're inverses of each other. So what this does is it says, we're going to use log. I don't really know where that comes from. The base of the exponent becomes what we're going to refer to as the base of the log. So this is a subscript. And then since they're inverses, these two values switch. So this becomes log base b of x is equal to y. So these two things mean the same thing. B to the y equals x is the same as saying log base b of x is equal to y. This number to this power equals this number. Let's get a little pointer going here. This number to this power equals this number. This number to this power equals this number. These two things are exactly the same. This is just a more convenient way for us to write it because it's in the form of y equals, so that's going to allow us to solve for this variable here. So if I go back to the example that I just made up on the last problem, if we were being asked 2 to the x power is equal to 15, and we were asked to figure out what that answer is, we could figure that out by rewriting this as log base 2, the base of the exponent stays as the base of the log of 15. These two things now switch equals x. And you would be right in asking how is this any more helpful than this, because this is just a bunch of gobbledygook right now. And my answer would be, hang on, we're going to get there, and you'll be able to see how to solve things like that pretty easily. Okay? Alright, but before we do that, what we're going to do today is we're mostly just going to practice with that basic idea of taking an exponential function and flipping it around and writing it in log form. So let's do that with this right here. If y equals 8 to the x, how do I rewrite that in logarithmic form? I would say log base 8, because remember the base of the exponent becomes the base of the log, and then they're inverses of each other, so these two things just switch. So log base 8 of x is equal to y. Okay? So this 8 right here, I don't know if you can tell, that's a subscript. It's a lower down below 8. So that's how you write this. Okay, so that's just what I was talking about. So a to the b equals c is the same as log base a of c equals b. The base of the exponent becomes the base of the log, and then these two values switch each other around. Okay? Alright, so let's continue to practice that because it's so stinking important. What is the logarithmic form of 3 to the 4th equals 81? So that would be log base 3, because the base of this exponent was a 3. And then I'm going to switch the 3 and the 81. So that is log base 3 of 81 is equal to 4. And again, the way that I would read that is, or do this mathematically, is this number, the 3, to this power equals this number here. This number to this power equals that number. Okay? Alright, let's go the other way. Let's take something that is already written in log form and rewrite it in exponential form. That's an important skill to have. So like I said with this example here, the way we do that is it's this number to this power equals that number right there. So in this case, that would be 10 to the third equals 1,000. Okay? So this is an example of starting in exponential form and rewriting it in log form. Here's an example of starting in log form and rewriting it in exponential form. Okay, so I would suggest that you pause the video, try these on your own. Let's get rid of that gross color. I will do these with you right now. Hopefully you did them on your own. What is the logarithmic form of 7 to the third equals 343? That would be log base 7 of 343 equals 3. The base of the exponent becomes the base of the log, and these two guys switch around. So the way I read this is this number to this power equals this number right here. Okay, how about if we go the other way around and we start with and we start with log, and we switch it around to being exponential. That would be this number to this power equals this number here, which in this case is 4 to the second equals 16. Okay, so that's how you translate in between those two formats. Alright, so let's do some easy ones of these, and we can practice our rules of exponents along the way. So let's evaluate some logarithmic expressions. So for this one right here, what we're asking is we're saying 5 to what power is equal to 125. And like I said, at this point all we have is just our math knowledge to help figure this out. 5 times 5 is 25. 5 times 5 times 5 is 125. So that means x equals 3. How about this guy here? Let's get a different color going for each box. Let's get crazy. So this is saying 1/4 to what power is equal to 16. Okay, so this gets a little bit of fun because we got to deal with fractions here. So the way that I'm going to do that is I'm going to pretend it's not a fraction first. So I'm going to say 4 to what power is 16, and that answer is, of course, 2. Then, since it's a fraction, I don't know if you remember this, but the way that you get fractions out of exponents is you make the exponent negative. So in this case, if I took 1/4 and raised it to the negative 2 power, I would get 16 as an answer. 1/4 squared is 1/16. 1/4 to the negative 2 is 16. Okay? Alright, let's do another color switch here. So then this says log base 3 of 0. What does that equal? So I'm being asked 3 to what power equals 0? Well, that's a funny question. There is no number that I can raise 3 to and get 0 as an answer. Remember, anything to the 0 power is equal to 1, but I can't raise a number to a power and get 0. So this one would have no solution. Try to trick us. Okay, and then the last one has a fun little trick in it that's going to be handy for us later. This is saying this base right here, 2 to the what power is equal to 2 to the 8th power. Well, to some of you that's going to be immediately obvious. 2 to the what equals 2 to the 8th. If these two bases are the same, then the two exponents have to be the same. So that means that x equals, not 9, x equals 8. And so what you might notice there is that if the base of the log and the base of the exponent are the same, those two things basically, so funny, cancel each other out and leave you just with 8. So in other words, if I made another one of those up just for funnies, if I said, for example, log base 7 of 7 to the 5th, then since this base right here and this base right here are the same, those are going to cancel each other out and give me just 5. So I could write that as a general rule, log base x. Okay, not sure where I left off there, but generally speaking, you could say log base x of x, come back, x to the whatever, y, that's not a y, dude, and that's not an exponent, to the y power. These two bases will always cancel, and you'll just end up with whatever the exponent is. Okay? Alright, so try these on your own. Pause the video, work them on your own, and then we will go through them together. Okay, so first one, log base 3 of 181st is asking 3 to the what power is equal to 1 over 81. So again, since there's a fraction involved here, what I'm going to do is I'm going to ignore the fraction, and I'm going to first figure out 3 to what power is equal to 81. And I can do that just by guess and check. 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's x to the 4th. And then to make this into a fraction, I just need to make that answer negative. So it's x to the negative 4. Okay? Alright, how about log base 7 of negative 7? So that is asking 7 to the what power is equal to negative 7. Well, sadly, there is no number that I can raise 7 to get negative 7. A lot of times students are confused by this and want to make x be negative. But again, if you make the exponent negative, you end up with a fraction. You don't end up with a negative answer. So this one has no solution. And then finally, this is the examples that we were just talking about on the previous slide. If I have log base 5 of 5 to the 9th, since these, this base and this exponent are the same, these things are just going to cancel out. And then I'm going to end up with 9 as an answer. Okay? Alright, so that's the basic introduction to logs. We'll talk about this more tomorrow. But base 10, because raising 10 to successive powers is easy because you just keep adding zeros. That's a very common base to use. So if you see something that just says log of 5, what that means is log base 10 of 5. So if there's no base written, then you can assume that that's 10. Another thing that we will do also is called the natural log. And the natural log has e as its base. I don't know if you remember from yesterday or the day before what e was. That came up when we were figuring out how to compound interest continuously, since e is called a natural number, you use the natural log to signify that as your base. And the reason why it's backwards is because ln comes from the French logarithme naturel, so the letters are switched, but ln is read as base e. Okay, that might come up in your homework a little bit. Alright, did I say homework? I mean problems that you can do because you want to better yourself as a human being. So here are some of those if you want to work on them, if you want to stay fresh with your math, keep learning, all that other good stuff. I will go through these after lunch and post that video so you can see if you have any questions. Alright, we'll do it again tomorrow. Take it easy.